Let's start the last topic of this chapter, that is transformer. So first of all we will see that in how many devices a transformer is used. So these electrical devices, voltage stabilizer, digital camera, laptop and mobile charger, all are containing of transformer. You can clearly see from this animation, all are having the transformer containing in it, and it is defined as an electrical device that is used to convert AC power of certain voltage level to AC power at a different voltage. That means we are changing the voltage but at the same frequency. And now we will switch on to the actual principle of it on which this transformer is working. And here the principle is shown that if two coils are inductively coupled and current changes through one of the two coils, then EMF is induced in the other coil, and you can see from the meter that current is keep on changing. So the arrangement is like this. First of all, we have to take rectangular soft iron cord, and it is insulated from the inside, and we are putting some coil. See, this P stands for primary coils and this S stands for the secondary coil. We are connecting the primary coils with an AC source which will supply the voltage or particular AC current in the primary coil, and to maintain the value of current flowing in the primary to secondary, we have connected the load resistance at the secondary coil. And the types of transformer are mainly of two. The first is step-up transformer and the second one is step-down transformer. The step-up transformer, in which the number of turns in the secondary coil, you can see from the figure, they are more than that of in primary coil. This primary coil is made up of thick copper wire, and this type of transformer, means step-up transformer, converts low voltage at high current to the high voltage at low current. Now we will see the another type of transformer, that is step-down transformer. The step-down transformer is very opposite to this particular transformer step-up. So in that, the number of turns in the primary coil will be larger than the number of turns in the secondary coil, and in which the type of transformer will convert this high voltage at low current to low voltage at high current. So in this, the high voltage is converted into the low voltage. So these are the mainly two kinds of step up and step down transformer. And now we will see the applications of transformer. So first of all, step down transformer is used for obtaining the large current for electric welding. Then we are aware with this particular application. The transformer is primarily used for transmission of electric energy over long distances, which you can also see from the figure. In the medical application also, the step-up transformer is used for production of X-rays. And at last, transformer is used in voltage regulators and in stabilized power supplies. So this is all about the introduction and characteristics of transformer and its types. And now we will switch on to the analysis of this kind of transformer. Let's start some analysis on the theory of transformer, but before that I am giving you some structural arrangement of that. So here is the arrangement is shown. This is the rectangular arm made up of iron core. This is the primary coil which is connected with the AC source, and here secondary coil. See, it is not shown over here that it is connected with the load resistance, but it is connected with at present the infinite load resistance, that means resistance of phase. And here you can actually see the winding of primary and secondary coil, and this is the symbol or the circuit symbol which is used to represent any transformer. Now some assumptions I am making over here, that this is phi p is the magnetic flux linked with primary coil, then phi s. See, this P stands for primary and this S stands for secondary. So phi s is the magnetic flux linked with the secondary coil and also I am defining some quantities, that number of turns in primary coil, that I am denoting as Np, and the number of turns in secondary coil, that is Ns. So here we have studied about the defining of four important terms. Now there is one relation, that the magnetic flux in the secondary coil and the ratio of magnetic flux in the primary coil is equal to the ratio of number of turns in secondary coil to the number of ratio in the primary coil. So this is the first important result which we have obtained. Now as the primary coil is connected with the AC source, then some kind of current is flowing through the coil or the transformer. Then according to the Faraday's law, as we know from the animation, the induced EMF is generated in the coil. So, induced EMF in the primary coil that is denoted by epsilon P, and we know the equation for that is minus d phi p, means the negative rate of change of magnetic flux connected or linked with the primary coil. So this is the second important result what we have obtained over here, and by the same law applying on the secondary coil, we will get the induced EMF as is given by epsilon s is equal to minus d phi s by dt, and that is the result number 3. Now from the first equation we have the value of phi s, that is phi p into ns over np. This is equation number 4, which is actually came from Equation number 1. And so, d phi s by dt is equal to, this number of turns are constant, so their ratio is also constant, into rate of change of flux in the primary coil or its flux. So this is the value of d phi s by dt, and therefore the value of epsilon s is equal to minus ns over np into d phi p divided by dt. But you see, first of all, these terms minus d phi p by dt, from equation number 2 we have the value epsilon p is equal to minus d phi p by dt, and therefore the induced EMF in the secondary coil is also related by this equation, ns by np into epsilon p. And now the ratio of induced EMF from secondary to primary is also related to the number of turns in the secondary to primary. Now, this is the constant number, and for this constant I am denoting it as a small r. So this is my equation number 5. Now, the value of this constant, how can you define? For step-up transformer, the number of turns in the secondary coil is larger than the number of turns in the primary coil. Therefore, in step-up transformer, R will always greater than 1. And similarly, if you look at for the step-down transformer, then in that case the number of turns in primary coil is greater than that of number of turns in the secondary coil. And so for step-down transformer, the value of constant R will be less than 1. Now, suppose the current flowing in the primary is IP and the current flowing in the secondary coil is IS. Therefore, when there is no power loss, in the transformer, then the instantaneous input power is equal to instantaneous output power. Now see here, input power we will study for primary coil because we have connected the AC source into the primary coil, and here instantaneous input power is equal to the instantaneous output power. Therefore, instantaneous input power is given by V into I, but here instead of V I am putting the induced EMF that is also working as voltage. So epsilon PIP is equal to epsilon SIS. And now again I am taking the ratios of the induced EMF. Epsilon S divided by epsilon P is equal to IP over IS, and we have earlier obtained from equation 5 this value as NS over NP. that is also equal to R. And this is also an important result, equation number 6. So the assumption what we have studied over here is an ideal, and the transformer which is having no power loss is called an ideal transformer. Similarly, this kind of ideal transformer are not practically possible, but there is some kind of power loss in the formation of eddy currents. So, the power loss practically possible in the formation of eddy currents also in the formation of or in the magnetization or demagnetization of the core. This core which is containing primary and secondary coil both. So such kind of power loss are practically possible, and so ideal transformer is, we can say, an imaginary concept of physics. And now we will switch on to the last illustration of your chapter, that is illustration number 15.